Hello everyone! Today's joke of the day is, why was Santa's little helper sad? Stay tuned to find out. Our learning target for today is I can solve and graph simple absolute value inequalities. So let's review again what absolute value is. Okay, well, absolute value is the distance between a number and 0. Okay, so that's the distance between a number and 0. Okay, and it is always a positive, right? Because we cannot have a negative distance. Okay, so we write it as this big bar with our variable in between, and then another bar. Okay, so 2 bars with a variable in between. So we're going to consider this following inequality. The absolute value of x is greater than 5. Well, we can split this inequality up into 2 different inequalities. Okay, just like with equations, our first one is always going to just be as we see it, but without the absolute value sign. So we'll have x is greater than 5. Okay? Our second one, well, we know that we're going to have an x still, and we're going to make that constant, that 5, we're going to make it negative, okay, just like we did with equations. But in this case, just like when we have to multiply or divide by a negative number in our inequalities, right, we flip the sign of the inequality, okay, we flip the inequality symbol. So this is actually going to be x is greater than 5 and x is less than negative 5, okay? This makes sense because when we take the absolute value, it needs to be greater than 5, okay? So we are looking for numbers that have an absolute value that's greater than 5, okay? You can also think of this as like a number that's more than a distance of 5 away, okay? So let's look at some examples, and maybe this will make a little bit more sense as to why we do it that way. Okay, so we're going to split the following inequalities and visually represent the solutions with a graph. Okay, so I'm going to write my 2 inequalities once they're split in 2 different colors. So the first one will just be exactly as we see it, but dropping the absolute value signs. Okay, a is less than or equal to 3. And then our second one is going to be we'll flip the inequality symbol, greater than or equal to, and then make that a negative 3. Okay, so if we were going to graph this, okay, it says visually represent. So we're going to graph this, and I will put 0, 3, and negative 3 on my number line. Then we just want to graph this as if it were a compound inequality. Okay, so we want a is less than or equal to 3. Okay, so we want all the numbers that are going to be less than 3, but also greater than or equal to negative 3. So we'll have closed circles at negative 3 and at 3, and then we will actually shade in between them, okay? Because those would be less than positive 3, but greater than negative 3. And this is going to be our solution, okay, to this absolute value inequality. All right, let's look at this next one. We have the absolute value of t is greater than 2. Okay, so we'll write our first inequality just as we see it, but without the absolute value bars. And then our second one, we will have t is less than, we'll flip the inequality symbol and make it a negative 2. Okay, so we'll have t is greater than 2 and t is less than negative 2. Okay, so then if we were going to put this on a number line, we have 0, 2, negative 2. Okay, and we want t is greater than 2, so we'll have an open circle at 2 and shade to the right. And then t is less than negative 2, we'll have an open circle at negative 2 and shade to the left. And that is our solution set for this absolute value inequality. Okay, so let's look at a few more here then. If we have the absolute value of r is less than 1, we'll split that into r is less than 1, okay, exactly as we see it. And then the second one will be r is greater than negative 1. Okay, we flip the inequality symbol and make that one a negative. Then if we're going to graph this one, we have 0, 1, and negative 1. Okay, so we will, r is less than 1, so we'll have an open circle at 1, and r is greater than negative 1, so again, open circle at negative 1, and we will shade in between those two here, because well, r is less than 1, and r is greater than negative 1. Okay, so this is thinking like we have any number that's no more than a distance of 1 away from 0. Okay. All right, let's look at this one here. We have our first inequality will be exactly as we see it, but without the absolute value bars. Our second one will be n, we'll flip that inequality symbol, so n is less than or equal to, and we'll make it a -4. Okay, so the absolute value of a number is going to be more than a distance of 4 away from 0. Okay, so if we're going to graph this one, it'll look like we'll have 0 here, we'll have 4 here, -4 over here. Okay, we want to be greater than or equal to 4, so we'll have close circle at 4 and shade to the right, greater than or equal to 4, and less than or equal to -4, so close circle at -4, shade to the left. Okay, these are all the numbers that are a distance of, or that are more than or equal to a distance of 4 away from 0. Okay, now we're going to solve the following inequalities and then again visually represent the solutions with a graph. Okay, these ones are a little bit different because there are some other things going on inside of those absolute value bars, but we'll solve them the exact same way. Okay, so the first, we'll split it into our two inequalities. Our first one will be x minus 4 is greater than 7, okay, exactly as we see it, but without the absolute value bars. Our second one will be x minus 4 is less than -7. Okay, so we'll flip that inequality symbol and make that 7 negative. So first thing we want to do here then is solve, right? We want to add 4 to both sides here to end up with x is greater than 11. And then we will do the same thing over here, add 4 to both sides to get to isolate that variable x, and we'll end up with x is less than -3. Okay, so in this case, our inequality will be x is greater than 11 and x is less than -3. Okay, that will be our solution set. Okay, so I will put -3 on here, 0, and then put 11 a little bit out here to try and make it a little bit more accurate. Okay, x is greater than 11 means we have an open circle at 11 and shade to the right. And x is less than -3 means we have an open circle at -3 and shade to the left. Okay, and this will be our solution set for this inequality. All right, let's look at one more here. If we have the absolute value of -2x minus 3 is greater than 5, we'll split it first. We'll split it into -2x minus 3 is greater than 5. Okay, exactly as we see it, but without the absolute value bars. And then we'll split to -2x minus 3, flip the inequality symbol, and make that 5 negative. Okay. Now we need to solve both of these, so we will add 3 on both sides. We'll get -2x is greater than 8. And then we want to divide by -2. So those will cancel out and we'll get x is, well, we divided by a negative, so we have to flip our inequality. So x is less than -4. Okay, and then solve this one here. Same steps, okay, just a little bit different numbers. We'll add 3 on both sides. Get -2x is less than -2. And then we'll divide by -2 on both sides, but when we divide by a negative, we have to flip our inequality symbol. So we'll get x is greater than -2 divided by -2, which is 1. Okay, so if we were going to graph this, we want x is less than -4 and x is greater than 1. Okay, so we'll put -4 on our number line, 0, and 1 here. So x is less than -4, open circle at -4, shade to the left. X is greater than 1, open circle at 1, shade to the right. Okay. Last thing we want to think about considering this inequality. The absolute value of x is less than -2. Are there any possible numbers for x? Well, let's think about what this reads. It is saying that there's a number that's a distance of less than -2 away from 0. Is that possible? Well, no, it's not, because we cannot have the absolute value of any number being a negative number, okay? We cannot have, right? Because all numbers less than -2 are going to be negative, right? So we can't have an absolute value of a number that is negative. Okay. All right, so now for our joke of the day. Why was Santa's little helper sad? It was because he had low elf esteem. Thanks for watching and have a great rest of your day.